Hello students, we are discussing Unit 11, that is alcohols, phenols and ethers. In our previous classes, we have discussed IUPAC nomenclature of alcohols and phenols, and then in our last class, we have discussed methods of preparation for alcohols. So in today's class, we will discuss chemical methods for preparation of phenols, and after that we will discuss important physical properties of alcohols and phenols, and then we will discuss chemical reactions of alcohols. So our heading is preparation of phenols. So the first method by which phenol is prepared is from benzene sulfonic acid. So in this reaction, first benzene is treated with oleum, that means a mixture of sulfuric acid and sulfur trioxide is known as oleum. Okay, so when benzene is treated with oleum, then benzene sulfonic acid is formed. This one is benzene sulfonic acid. And now when the benzene sulfonic acid is treated with sodium hydroxide, and after that acid hydrolysis, or after that when we added an acid, then the benzene sulfonic acid is converted into phenol. That means the final product is phenol. So in exam, question is asked, how can you convert benzene into phenol? So to convert benzene into phenol, we have to follow these steps. That means at first, when benzene is treated with oleum, then benzene sulfonic acid is formed, and then when benzene sulfonic acid is treated with sodium hydroxide, and then acid hydrolysis, or we can add one acid because already water is present in acid, and then after acid hydrolysis the final product is phenol. Okay, so our next method is number B, form aryl halides. So you have studied about aryl halides in chapter 10, that is haloalkane and haloarenes. Now we will take an aryl halide, that is chlorobenzene, and when chlorobenzene is treated with sodium hydroxide at 623 Kelvin temperature and 300 atm pressure, okay, then the chlorobenzene is converted into sodium phenoxide, ONA. This one is sodium phenoxide. Okay, and when sodium phenoxide is treated with HCl, then the final product is phenol. The final product is phenol. So we have converted chlorobenzene into phenol. Okay, first chlorobenzene is treated with sodium hydroxide at 623 Kelvin temperature and 300 atm pressure, and then chlorobenzene is converted into sodium phenoxide and the sodium phenoxide is treated with HCl, and then the final product is phenol. So we can prepare phenol from aryl halides also. The next number C, from diazonium salt. From diazonium salt. So about diazonium salt, you have studied in chapter 10. So you already know that when aniline is treated with, this one is aniline. When aniline is treated with nitrous acid, the mixture of sodium nitrite and HCl is known as nitrous acid. At 0 to 5 degrees Celsius, then benzene diazonium salt is formed. This one is benzene diazonium salt. And when diazonium salt is treated with water, then water will break to form H positive and OH negative, and this OH negative will replace whole the diazonium group. That means the final product is OH. Okay, after that the side products are nitrogen gas, and then this H positive will combine with Cl negative to form HCl. But in case of organic chemistry, no need to write the side products because only main product is necessary. So we have converted aniline, this one is aniline, into diazonium salt, and then finally the diazonium salt is treated with water to get phenol. So in exams, questions will ask, how can you convert aniline into phenol? So to convert aniline into phenol, you have to write this chemical reaction. Again, questions will ask, how can you convert chlorobenzene into phenol? So to convert chlorobenzene into phenol, so you have to remember this reaction and you can take this reaction. Okay, and then the next method is from cumin. So number D, from cumin. From cumin. Okay, this compound is known as cumin. This compound is known as cumin. Okay, and now when cumin is treated with atmospheric oxygen, then the product is this one. Okay, that means this carbon is benzylic carbon. The sp3 hybridized carbon next to a benzene ring is known as benzylic carbon, and benzylic carbons are very active. Okay, and due to activeness of this carbon, the oxygen will get attached with this carbon, forming peroxide bond. When oxygen single bond is present, that bond is known as peroxide bond. Okay, now this product is hydrolyzed with an acid, and during hydrolysis the peroxide bond will break. Because peroxide bond is very weak bond, oxygen generally form double bond with each other. but in this case single bond is present and peroxide bond is hence very weak bond. Therefore the bond will break here. Again this bond will break. You can remember like this, okay? And then after breaking the bonds, the OH will attach with the benzene ring and CH3 C again CH3 double bond O. That means here one double bond will form. Acetone will form. That means the products are phenol and acetone. So we have converted cumene, this one is C, cumene into phenol. At first cumene is treated with atmospheric oxygen, then this compound is formed, and the name of this compound is cumene hydroperoxide. Cumene hydroperoxide, okay, because peroxide bond is present. And when this compound is hydrolyzed with an acid, then the peroxide bond is break and carbon-carbon bond is also break, okay, and after that phenol and acetone are formed. So we have converted cumene into phenol. So we have studied 4 methods for preparation of phenol. So in first method we have converted benzene into benzene sulfonic acid, okay, and after that on treating benzene sulfonic acid with sodium hydroxide followed by hydrolysis, the final product is phenol, okay, and then we have converted chlorobenzene into phenol. So about that reaction you have studied already in chapter 10, that is haloalkane and haloarine. And then we have converted benzene diazonium salt into phenol. At first aniline is converted into diazonium salt, and then after treating the diazonium salt with water we get phenol, okay, and then we have converted cumene into phenol, okay. So these are 4 important methods for preparation of phenols. So we have completed chemical methods for preparation of alcohols and phenols. So chemical methods for preparation of alcohols we have already studied in our previous class, that means last class, and in today's class we have studied preparation of phenol, okay. Now we will discuss physical properties of alcohols and phenols. Physical properties of alcohols and phenols. Okay. So when we will study physical properties, then the first property is number 1, solubility. And you have to remember that lower alcohols are always soluble in water because alcohols can form hydrogen bonding, intermolecular hydrogen bonding with water, okay. But higher alcohols are insoluble in water because in case of higher alcohols, the alkyl group is very large. Therefore, due to steric hindrance, the hydrogen bonding become weak, okay, and hence the higher alcohols are insoluble in water, okay. And after that we have to discuss number 2, that is boiling point. Okay, and now the boiling point of alcohol is always higher than ether. of same molecular mass. Suppose we are considering C2H5OH ethanol, and then the boiling point of ethanol is always higher than methoxymethane. This one is ether and this one is alcohol, and the result is due to formation of intermolecular hydrogen bonding in alcohol. Alcohol can form intermolecular hydrogen bonding because in this case the hydrogen is attached with the oxygen, and when hydrogen is attached with oxygen, nitrogen and fluorine, then intermolecular hydrogen bonding is formed. Okay, so in this case intermolecular hydrogen bonding is present, but in this case carbons are attached with oxygen. Hydrogen is not attached with oxygen, only carbons are attached with oxygen. Therefore in this case intermolecular hydrogen bonding is not present, and hence the boiling point of alcohols is higher than ethers of same molecular mass. Both of them have same numbers of carbon, same numbers of hydrogen and same number of oxygen, so they have same molecular mass, but boiling point of alcohol is higher than ether. So in exams questions asked why the boiling point of ethanol is higher than methoxymethane, explain. So you have to write that in case of ethanol intermolecular hydrogen bonding is present, but in case of methoxymethane intermolecular hydrogen bonding not present. Therefore the boiling point of ethanol is higher than methoxymethane. Okay, again question will ask, explain why lower alcohols are soluble in water. The reason is same. Lower alcohols can form intermolecular hydrogen bonding with water. Therefore lower alcohols are soluble in water. Okay, but higher alcohols are insoluble in water. Similarly phenol is also insoluble in water, because in case of phenol the size of aromatic ring is very large, hence this ring will prevent to form intermolecular hydrogen bonding with water. Therefore phenol is also insoluble in water. So we have discussed two important physical properties of alcohols and phenols which are very important. Okay, now we will discuss chemical reactions of alcohols. So in today's class we will discuss few chemical reactions of alcohols, and after in tomorrow's class we will discuss more chemical reactions. After that we will discuss chemical reactions of phenols. Okay, so our heading is chemical reactions of alcohols. Chemical reactions of alcohols. Phenols have some exclusive chemical reactions, and about those chemical reactions we will study after studying chemical reactions of alcohols. Okay, so first we will discuss reactions involving breaking of oxygen hydrogen bond. That means in case of alcohol, suppose we have considered this alcohol methanol, this one is methanol. Okay, here in case of alcohols two bonds can break. This bone can break, again this bone can also break. So that means in case of alcohols, two bonds can break. But first we will discuss the chemical reactions which are due to breaking of this bond. Okay, after that we will discuss the chemical reactions due to breaking of this bond. So our heading is reactions involving breaking of oxygen hydrogen bond. Okay. Now in this case, at first we will discuss acidity of alcohols. Okay. Now suppose we have considered CH3OH. Okay. So in this case, the electronegativity of oxygen is higher than hydrogen. You have already studied about electronegativity in class 11. Okay. So electronegativity of oxygen is higher than hydrogen. Therefore, due to higher electronegativity, oxygen will attract the electrons towards itself, resulting release of H positive ion. When oxygen will attract the electrons towards itself, the H positive ion will release, and you already know that according to Arrhenius concept, species which lost H positive ions are called acids. Okay, that means due to loss of H positive ion, alcohols have acidic property. Okay, and this acidic property can be finalized, or this acidic property can be determined by this chemical reaction. Suppose we have considered a general alcohol, ROH. When this alcohol will react with active metals like sodium, lithium, okay, potassium, then salt will form, RONA, sodium alkoxide, and then hydrogen gas will liberate, and which will burn with pop sound. Okay, so that means we have already know that when acid react with metal, then salt and hydrogen gas is formed. So alcohol is showing the properties of an acid. Therefore, alcohols are acidic in nature. So this reaction proves that alcohols are acidic in nature. Okay, we will balance this equation. We have to put 2 here, then 2, and again 2. So this reaction proves that alcohols are acidic in nature. Similarly, phenols are also acidic in nature, because phenol also react with sodium metal to give sodium phenoxide and hydrogen gas. So both alcohols and phenols are acidic in nature. So these two chemical reactions prove that alcohols and phenols are acidic in nature. But now we will compare the acidity of alcohols and phenols. So you have to always remember that phenol is more acidic than alcohol. Phenol is more acidic than alcohol, because when phenoxide ion is formed, this one is phenoxide ion, this one is phenoxide ion. Okay, suppose sodium phenoxide, we are considering at first sodium phenoxide. So when the sodium will removed as Na positive, then this one is phenoxide ion, and the phenoxide ion is stabilized by resonance. The phenoxide ion is stabilized by resonance, and about resonance you have studied in class 11. That means this electron pair, in this case, 3 lone pair of electrons are present, and due to presence of an extra electron, negative charge will appear, and one lone pair will come in between the oxygen carbon bond, resulting double bond, okay, and due to formation of double bond here, the electrons of this pi bond will repel to this carbon. Therefore, here one negative charge will appear. There is no any sense in these bonds, therefore they will remain same. Okay. Now these electrons will come here. Okay, that means in between these two carbon, and then this pi bond will repel to that carbon. So that means here one double bond will form. After that, one negative charge here. Due to presence of lone pair of electron, no changes in these positions. Okay, and then again resonance will occur, and you have already know that higher the resonating structures, higher is the stability. Higher the resonating structure, higher is the stability. And due to stability of phenoxide ion, the H positive will not again attract it with, I will show you. Okay, and due to resonance, when phenol loss H positive ion in the solution, both H positive and phenoxide ion is present, and this H positive will not attract the phenoxide ion again. Okay, that means in the solution H positive ion will remain as free ion, and due to presence of these free H positive ions, phenol is more acidic than alcohols. Okay, the first reason is this one. So in exam question will ask, explain why phenol is more acidic than alcohol. So you have to write that in case of phenol, the phenoxide ion is stabilized by resonance, and hence the H positive will not again combine with the phenoxide ion. Therefore in this solution free H positive ions are present, and hence phenol is more acidic than alcohol. Okay, now let us consider 3 alcohols. One is primary, after that one is secondary, and then tertiary. Now we will compare acidity of these alcohols. Suppose we have this alcohol CH3 OH. We are considering 4 alcohols. First one is methyl alcohol, CH3 OH, and then let us consider one primary alcohol CH3 CH2 OH, and then suppose CH3 CH CH3 OH secondary alcohol, and then let us consider finally one tertiary alcohol. Okay, and now if we compare, then the acidity of methyl alcohol is higher than primary alcohol, and then the acidity of primary alcohol is higher than secondary alcohol, and the acidity of secondary alcohol is higher than tertiary alcohol. The reason is, when alkyl groups are present, then positive inductive effect is present, that is plus I effect is present, and about plus I effect you have already studied in class 11. Okay, and this one is primary alcohol, this one is secondary alcohol, and this one is tertiary alcohol. Okay, so due to presence of plus I effect, therefore the acidity decreases from primary to tertiary. That means these groups will not attract the electrons towards themselves, but they will pull the electrons away from them. Therefore, the H positive ion will not release easily. Okay, hence the acidity decreases. So we have studied about acidity of alcohols and phenols. Okay, now we will discuss another chemical reaction which is involved due to breaking of oxygen hydrogen bond, and the reaction is esterification reaction. Esterification. So number B, esterification. So you have already know from class 10 that when alcohols react with, suppose we are considering this alcohol react with carboxylic acid, this one is carboxylic acid. Okay, then oxygen hydrogen bond will break, and then in this case oxygen carbon bond will break. In case of carboxylic acid, oxygen carbon bond will break. Okay, and the side product is water, and then we will gain CH3 CH2 O C double bond O CH3. So this compound is known as ester, and the chemical reaction is known as esterification reaction. Okay, but this reaction is take place in presence of an acid. Okay, so we are taking another example. Suppose this reaction CH3 CH2 COOH react with C2H5OH in presence of an acid. What is the product? So the product is CH3 CH2, okay, CO, because in case of carboxylic acid the OH group was left. Okay, CH3 CH2 CO. Okay, and now in case of alcohol the hydrogen was removed, and due to removal of hydrogen this oxygen will form bond with this carbon atom, and the result is this one, and this one is also an ester. So we have studied about esterification reaction. So in our today's class we have discussed methods of preparation of alcohols. After that we have discussed physical and chemical properties of alcohols, and in physical properties we have also studied physical property of phenols, solubility and boiling point. Very important topic for exam purpose. And after that we are discussing reaction involving breaking of oxygen hydrogen bond. So in this case we have studied about esterification reaction, and at first we have studied about acidity of alcohols and phenols. And also remember that other than carboxylic acid we can also use acid chloride. But when acid chloride is used, then the side product is HCl, because this hydrogen will combine with chlorine to form HCl, and due to presence of this HCl the reaction will become reverse. Okay, that means ester will break to give acid chloride, and then alcohol. Therefore, the reaction is carried out in presence of a base, and the base is pyridine. This base will neutralize the HCl. Therefore, the reaction will take place only in forward direction. Okay. So, we have again studied another example of esterification reaction. So, in our next class, we will discuss reactions involving breaking of carbon-oxygen bond. And we will again study about exclusive chemical reactions of phenols. So, that's all for today's class. Thank you.